In this presentation, I'll be talking about the Matai'an River Barrier Lake disaster that happened earlier this year in Taiwan. A barrier lake forms when a river is blocked by landslide deposits, causing the water to pile up upstream. The landslide can be triggered by, for example, heavy precipitation, earthquakes, or volcanic eruptions. In this event, it was triggered by a typhoon. Because the landslide deposits are weak, the dam eventually collapsed during another typhoon on September 23rd of this year. This sent up to 8,000 cubic meter per second of water down the Matai'an River, which flooded several towns downstream, particularly the Guangfu Township, and destroyed the Matai'an Bridge. The flood resulted in many casualties and is the deadliest typhoon-related disaster in Taiwan since 2009, and likely the deadliest barrier lake. Barrier lakes are not particularly common in Taiwan, so many people were caught off guard. To understand why the event occurred at Matai'an, we must look at the geological and climatological background. So the eastern Taiwan is very geologically active. The north-south oriented valley that you can see on the map is a major fault zone that basically represents the plate boundary between the Eurasian plate on the west and the Philippine plate on the right. This means that this area is experiencing active mountain building, which creates a steep slope and also many earthquakes that form an ideal environment for landslides to happen. And at the same time, the entire island of Taiwan is located on the edge of the Asia continent in the tropics to subtropical region, meaning that the climate here is strongly influenced by the East Asian monsoon, and it is therefore already very warm and humid. And typhoon in the Pacific Ocean brings a lot additional rainfall. So Taiwan, and especially the part of the island that Matai'an is in, is very prone to compound geologic and meteorological hazards. With this barrier lake disaster, each individual event that led to it is considered extensive. They are relatively common. But because how they set up this subsequent event, the consequence was a highly intensive disaster that people were not properly prepared to address. So the specific sequence of events that ultimately led to the collapse of the barrier lake is as follows. So in April of 2004, a magnitude 7.1 earthquake struck Hualien, and its epicenter was just tens of kilometers north of Matai'an, and it was the largest earthquake in Taiwan since 1999, and it destabilized many hill slopes in the area. And consequently, when Typhoon Wipa struck this July, the soil was very, very loose, and the landslide took place more easily and formed the barrier lake. And in August, another typhoon struck, which placed more stress on the lake dam and accelerated its failure. And finally, in September, Typhoon Regasa finally pushed the lake to the critical point, and the overflow occurred on September 23rd, flooding the downstream. And the barrier lake was not completely destroyed, though. It was still there, and in fact, it is still there now. It's just much smaller. So the typhoon Fengwang this November caused another smaller outflow event and destroyed some temporary infrastructure and restoration efforts. But fortunately, there was no death or major casualties associated with the outflow this time. And the immediate aftermath of the barrier lake collapse was catastrophic. There was 19 confirmed deaths and nearly 160 injuries. As I mentioned earlier, these numbers make this one of the deadliest typhoon-related events in Taiwan. But the damage extended far beyond the initial flood wave. Economically, the region suffered direct losses of over 8 million USD, primarily devastating the agricultural sector. And this value does not include the cost of home or infrastructure like restoration that is going to cost down the line, or associated health issues or long-term economic damage, which could easily push this number much higher. And the related infrastructure collapse also played a major role in amplifying the chaos after that. So there was 42 base stations down and the Matai'an Bridge was destroyed, so communication was difficult exactly when it was needed the most. And over 4,000 households lost basic utilities like water and electricity. meaning that the crisis continued after the floodwaters receded. And the long-term environmental impacts because of this massive sediment deposition in the valley is still unclear and it probably takes, maybe a decade to really become clear. And we also have to take a look at the demographics of the Guangfu Township to see who is the most affected. So Eastern Taiwan as a whole has a population loss problem. So as we can see from this population pyramid, which is like data from just this September, we can see that the community is heavily skewed toward the elderly. In fact, 29% of residents in Guangfu are above the age of 65. This is significantly higher than the national average of 20%. So this had a direct impact on evacuation efficiency. Many residents either are not that familiar with technology to receive the notice, or simply could not move quickly enough, or was not willing to move to leave their homes without assistance. Furthermore, this region is predominantly occupied by the indigenous population of Taiwan, which accounts for 55% of the residents. This is significantly higher than the 3% national average. So we are looking at the elderly and the indigenous people whose income likely depends on agriculture or tourism and is not super stable. This shows a huge environmental justice issue where marginalized communities are often located in the most geographically vulnerable, high-risk mountainous zones. So now I want to take a step back and see what actually worked during the disaster response and what didn't. On the positive side, some of the engineering and preparation downstream did help. The dredging and reinforced embankment near the populated areas probably prevented the flooding from spreading even further. And socially, the response from the public was very strong. Donations and volunteers arrived very quickly, which helped the communities recover faster. But there were also major failures. The bigger issue was risk assessment. So it was underestimated how quickly the barrier lake would fail. And because Taiwan rarely encountered these events, the government had little experience handling this kind of disaster. And another major problem was the evacuation protocol. So the authority allowed what is called the vertical evacuation, meaning that while people were notified to evacuate, they could simply move to higher floors instead of relocating entirely. So this likely created a false sense of safety, and when the flood wave arrived, those buildings offered far less protection than expected. Although I will also note that there are also accounts that people just didn't receive any warning. So overall, while some protective measures helped, the gaps in hazard protection, perception, and evacuation planning pretty significantly worsened the impact. So looking forward, there are several improvements that could meaningfully reduce the future barrier lake related or other kinds of low frequency intensive disasters. One would be monitoring on the monitoring and engineering side. So the biggest need is persistent real-time monitoring of high-risk mountain catchments. So this could be installing permanent ground sensors to make better use of satellite and drone imagery, or using different kinds of remote sensing or in situ seismometer techniques to let us detect unstable slopes and new lake formations earlier. And we also need engineering plans ready in advance. For example, controlled drainage channels or rapid deployment barriers so that mitigation could begin before a collapse becomes inevitable. And the next is warning and risk communication. So the alerts have to be reliable to reach remote and indigenous villages and elderly communities who may not be that familiar with new technology, but are also among the most vulnerable. And warnings also have to communicate how urgent it is very clearly. So, as I say, many residents reported that they did not understand the severity of the hazards, so messaging should be very direct, and be supported by other kinds of community-based outreach. And finally, we need clearer government rules. Taiwan's central and local government have to coordinate better, with responsibilities defined ahead of intensive disasters. So local governments and mountainous regions should also receive additional training, staffing, and equipment so they can manage evacuations quickly and effectively. And these steps won't prevent barrier links from forming. The geology of Taiwan makes that almost impossible, but they can prevent a dangerous situation from turning into a major disaster. So another big question after the disaster would be whether climate change played a role in this event. And in this case, I would say the connection is not very straightforward. So first, barrier lakes are not super common in Taiwan in the first place, so we have very few data points to rely on. So if we just look at the rainfall in 2025, which I'm showing in this cumulative rainfall plot, actually, the rainfall this year isn't abnormal by any means compared to previous year with even crazier rainfall. Sure, there were several heavy rain events, but none of them set any new records. So I would say what really makes the event stand out is probably the April 2024 magnitude 7.1 earthquake, which significantly destabilized the regolith in this region. Without that earthquake weakening the slopes, the landslide that created the barrier lake might not have happened or be sufficient to dam the stream in the first place. So the primary trigger, I would say, was tectonic rather than climatic. But that being said, climate change could still influence similar events in the future. Even if 2025 rainfall wasn't extreme, the long-term trend in Taiwan shows increase in short duration, high intensity rainfall over the board, which does raise the likelihood of future slope failures and flooding. And this more extreme rainfall can also make accurate forecasts more difficult. So to conclude, barrier lakes are among the fastest evolving and yet intensive natural hazards in Taiwan's mountainous regions, and people are not familiar with them yet. And while the event is not directly linked to climate change, more extreme rainfall in the future and more frequent slope failures mean that the conditions that create the barrier lakes are becoming increasingly common. So because of this, improving preparedness is very essential. That would include earlier detection, clearer communication, stronger evacuation planning, and better coordination across government levels. So if we take these steps now, we can greatly reduce the impact on future barrier lake disasters.